So you already know what Docker is and what it does. In this video, I will show you hands-on examples of when and where you can start using Docker in your apps today. So let's do it. I'm CJ, welcome to Syntax. So in this video, I am going to be using Docker Desktop, but you should know they have a license that says if you work at a larger company or a company that makes a lot of money, you do have to purchase a license. But it is free for personal use, education purposes, and non-commercial purposes. But if the license agreement does not agree with how you're going to be using Docker, there are alternatives such as Podman Desktop, Rancher Desktop, OrbStack, which works on a Mac. There's also a command line tool called Colima that works on Mac and Linux. But in this video, like I said, I'm going to use Docker Desktop. But if you use any of those alternatives, everything I show you will work there as well. Now, your first example of using Docker is to use the Docker CLI to temporarily spin up a container. Now, for this example, I'm going to run this Pokemon Cacher API that caches responses from the Poke API inside of a Redis database. Now, to run this locally, I would need Node, npm, and Redis. I don't have Redis, so there's a few ways to go about getting it. Now, the first way is to just install it on my local machine, and the instructions are going to vary depending on what operating system I'm on. I could also install it on a remote machine like a Linux VPS and then connect to that remote instance. I could also spin up a cloud instance, but I might actually have to pay for that cloud instance and then connect to that cloud instance. Or I could use Docker to run Redis locally inside of a container. Now let's get this app running on my machine. If you'd like to follow along, the link to this repo will be in the description, and you can just clone it down and follow along with what I'm doing. So I'm going to clone this here in this directory and then go through the setup, which tells me that I need to do an npm install. Great. And then I need to create my own environment variable file. So I will run this command, then we'll open this up with VS Code and edit it further. We can see that this example.env is attempting to connect to Redis here on my local machine on port 6379. And if we try to start up the app, let's just do an npm run dev. We will see that it's attempting to connect to Redis, but there is no instance running on port 6379 on my machine. So let's fix that by running Redis with the Docker CLI. Now, for any type of image that you're looking for, you can always use Docker Hub. There are other sites as well, but Docker Hub has all of the official images listed. And for example, we're on the Redis image here. But if you wanted to run MySQL locally, there is a MySQL image. If you wanted to run Postgres, there is a Postgres image. Pretty much any major service that you can think of, there is an image already on Docker Hub that you can just run locally. So for any of those images, take a look at their page on Docker Hub, and they typically have just like a one-liner that you can run that will actually start up that container. So let's actually just run this command and see what happens. So first, if you've never pulled this image before, it is going to have to pull that image down, and then it's going to save it onto your machine. But after it has pulled the image, the container is actually running. And if you run docker ps, you can see there is a container running. However, we have not exposed the port. The Docker PS will tell you that, hey, this container is listening on port 6379, but we need to expose that to our local machine. You could also see this inside of Docker Desktop. So if you pull up Docker Desktop, you'll see that there is a Redis container running. Also, if you take a look at images, you'll see that image that it downloaded. And then also, most images also have some sort of volume associated with them. And this is where they're storing the data for that specific containers, because containers are temporary, but any changes are saved in this volume here. But if I want to connect to this, I'm going to need to expose that port. So the first thing I'll do is actually, I will just stop and kill this container. And then I want to create a new container that actually exposes that port so I can connect to it on my local machine. Now, to figure out what port that is, you can always look at the docs for whatever service you're using. We know that Redis runs on port 6379, so we're going to add that into the command here. So if you run the command they gave you, but you also add a -p. So -p stands for exposing a port. And in this case, we want to expose port 6379 on our local computer. And we want to link that to 6379 running inside of the container. Now, if you already have something running on your machine on 6379, you could pick a different port like that. But this is just the port that will be available on your machine. So in the codes here, I could set this to anything I wanted, but I would just need to make sure that that matches this value here. But now when I run the container, it will expose that port. The other option you see here is -d, that stands for detached. But if we wanted to run in the foreground to actually see the logs, we can actually just remove that -d and now try running it. So there we go. Redis is running and the port is exposed. Now to check this, we can use docker ps. So if we do docker ps, we'll see that the container is running, but you definitely want to see this. This actually tells you that the port is exposed. So this is the port inside the container, and then this is how it's exposed on your local machine. So now if I start up my node.js app, it should be able to connect to that port, but we're getting a different error now. Now it's saying that we have the wrong username and password. Now to find or set this username and password, you can usually look at the docs for any container that you're running locally, but this Redis instance actually is running in non-protected mode, which means we can connect without a username and password. So for this specific use case and this specific type of container that I'm running, I'm just going to remove the username and password and then try starting up my app again. Great. So now the Redis container is running on 6379. We have our Node.js app running on 5000, and I should be able to visit it in the web browser. Cool. And then if we look at the docs for this API, we can see that /API v1 /Pokemon is what we can use. And then we'll just specify a Pokemon name like Pikachu. And we get back the response. So we know that this API is running and it's able to cache those responses inside of Redis. Now, there are a few other things we can do with this container here. So I showed you earlier, we have the docker ps command. This will show me all of my running containers. And you can reference a container by its ID or its friendly name. And in our case, when we started it up, we gave it a friendly name. So if I do a docker stop of some Redis, that will actually stop the container. And then you can see that node is freaking out because it doesn't have anything to connect to. If I want to start it back up, I can do docker start, pass in the name, that'll start it back up. And then Node.js should start to connect to it and not throw errors anymore. But you might want to be able to see the logs inside of that container. So if you do docker logs and then specify the container name, that'll spit out all of the recent logs. Now, the other thing you can do is you can follow these logs. So right now this just spits it out and then gives me back my terminal. If I pass in a -f, this will just stay there, and any new logs that come in, you'll see those happen as well. Now, there's a lot of things you can do with the CLI, and even I don't have these commands memorized. I had to look them up for this video. But if you want to learn more, check out the docs. They have the docs on the main Docker CLI command, but it's important to note that there are a bunch of sub commands. And so specifically, there is the container sub command, and that is actually where things like start and stop and logs, that's where all of these sub commands come from. They're just alias, so they're easier to run. But if you want to control your containers from the command line, you can look here for all of the other commands that you can use. Now, personally, I just use Docker Desktop because it's super easy to just go click the stop button, click the play button. I don't have to memorize any sort of commands or anything like that. And then the other thing that's nice is when you remove a container here, behind the scenes, it automatically removes any like associated volumes. You don't have to run special commands for that. But you can go either way. You can use Docker Desktop, you can use the CLI. Now, in the next section of this video, I'm going to show you how we actually don't even have to use the CLI at all, because if we want this to be a reusable process, right? Let's say there are other people on our team. We want them to be able to run Redis locally. Technically, we could put this little command here in our README, and then you can tell other people, hey, just go run this command and you'll get yourself a Redis container. But a better way to kind of like wrap that up and make it reusable is with Docker Compose. And Docker Compose is typically how I use Docker and how I'm even interfacing with Docker that's running on my machine. Next, let me show you a quick and easy example of Docker Compose. So take this command that we ran earlier, where essentially we specified an image name from Docker Hub, and then we ran it and we exposed a port. We can replicate that inside of a Docker Compose. So here in my code base, I'm going to create a file called docker-compose.yml. And then inside of here, I'll specify my services. Now, I'm getting autocomplete. That's because I have the Docker extension installed inside of VS Code. I recommend it. And then from here, we can specify all of our services. In this case, I just have one service. You can give it a name. If we wanted the exact example, we could call it some Redis, but I like to be a bit more descriptive. So I'm just going to call this DB. And then we specify the image that we want. Now, from the command line, we said the image name was Redis. So I'll add that here. And then from the command line, we also said that the port exposed is 6379. So there's a ports option in here, and we can just do 6379 and 6379. And there we go. And so I would actually commit this file to source code so that other developers can instantly spin up this Redis instance. Because now that we have this file, I can just do a docker compose up. It'll look at that file, see all of the images that I need, spin up all the containers that I need, and I'm good to go. And then if I kill this, it's going to stop all of those containers, and I'm done. So this is honestly the most of how I interact with Docker is I just have compose files that specify all of the images that I need to run, and also like custom images, which we'll talk about in a later section in this video. Now, an important thing to note here is the image section here. When you specify just the image name bear like this, it's just using the latest version of that image. And pretty often you want to specify a specific version. And so on the Docker Hub page, you can see all of the versions that are available. And for instance, we might just pick the latest, which is 7.2.4. So I might just lock this down and say, pull the 7.2.4 image. And now, just in case there's like breaking changes in the latest version, our compose file at least locks it down to a specific version. Now, there's a few other things we can do in this file. We'll get more into it later in this video. But for now, one thing of note is that you can also use environment variables. So for instance, we have this environment variable Redis port that we want to use. And if you want to use that inside of a compose file, you can just do $, curly braces, and then the environment variable name. Now, by default, Docker will look at the current folder, and if it sees a .env file, it's actually going to read in those environment variables. You don't have to do anything special. But now this is actually linked to our environment here. So if I were to specify a different port here, now when we spin up the container, it's going to expose that port instead. And because I specified it inside of that .env file, my Node.js app is actually also going to use that port to connect to the service. And so everything is still working here as well. This next example will be a slightly more complicated use of the Docker CLI and then also Docker Compose. So for this, I want to run this API called Backpack Debuggers. It's part of the Backpack Debuggers game, and it gives you an API. It's running Node.js and Express, and it has a few more requirements. So we're also going to need the ImageMagick CLI, and we're going to need a Postgres database. So I'm just going to get this thing cloned down locally, and then we'll try to get it running by spinning up a Docker container with Postgres inside. So let's clone it down. And then if we look at the docs, they say we should run an npm install. So let's do that. And from there, we will create an example.env file. And now we need a database in order to migrate and seed it. So if I open up VS Code here, and then we take a look at the .env, we're going to need a Postgres database that allows us to connect to it with this info. So if we look at Docker Hub for Postgres, similar to like the Redis image that we saw earlier, they give us a nice little CLI command that we can run. But it's going to be a little more complicated than this because we have other environment variables that we need to specify, like the database name and the database user. But let's start here. So I'm actually just going to copy this command, and then we're going to figure out the full CLI command that we need. I'm just going to put it in my README because I don't want to like be editing text in my terminal. Okay, so we're going to start here. We'll give it a name. In this case, we'll just call it backpackdb. And then we need to specify these other environment variables. So if we take a look in the .env, we're going to want the password to be super secret. And then we need to figure out how to specify these other environment variables as well. What's nice about the Postgres image is they actually have docs here on all of the other exposed environment variables. So the Postgres user is also exposed, and we can specify that. So in our command, we'll do -e, Postgres user, and then we can make it match up with our .env. So that'll be bpdebug, like that. Now we also need one for the database name, and they expose another environment variable, PostgresDB. So let's set that. So we'll do -e, PostgresDB, and then we want it to be backpack debuggers. Like that. And that should be all the environment variables because we are connecting to localhost. The last thing is we need to expose the port. And so this is always going to be -p, but the port that we expose will change depending on the kind of service that you're running. In our case, 5432 is the default port for Postgres. So I'm going to expose 5432 on my local machine and connecting to 5432 inside the container. So this should do it. Let's try running this command, and hopefully we get ourselves a nice little Postgres image running locally. So yeah, just like last time, because we don't have the image, it's going to have to download it. But it'll only have to do this once, and then from here on out, it'll use the downloaded image. So it looks like it's running. If we do a docker ps, yep, so it's running in the background. The port is exposed. So let's try running the commands in the README here. So let's try migrating the database. It didn't fail. I'm going to assume it worked. And then let's try seeding the database. All right. And then we'll spin up the app. So npm run dev. And let's see if we can get some monsters. It works. Awesome. So I was able to get a container running. I specified all the same connection info. So that way my node.js app connects to the same database that's running inside of a Docker container. Now, this is very cumbersome, right? I don't have to run this from the command line every time. So this is a much better use case for Docker Compose, where we can take all of this and wrap it into a nice compose file. So just like last time, we will create a file called docker-compose.yml. We'll specify our services. We have a DB service. Our image is going to be Postgres. But again, we want to specify the version number. So let's look at their docs here. Let's grab 16.2. And then we will specify the ports. And this needs to be 5432 and 5432. Now we need these environment variables. So here we'll say environment, and we'll specify the name. But here we can use our own environment variables from our .env file as well. So for example, Postgres password needs to match up to DB password. So let's specify that here. And then we need our Postgres user, and that needs to match up to DB user, etc. So let me fill out the rest of these, and then we'll see if we can spin it up. Okay, this looks good. We've got image name, the exposed port. Actually, this needs to be from our environment variable as well. So this is DB port. Cool. So this is the exposed port, the port inside the container, and then we have our other environment variables. This should be all we need. So let's go ahead and stop this container that we just spun up from the command line directly, and then we'll run Docker Compose up. So we're going to kill our API. We'll do a Docker Compose up. It's got our image, and then we can see it's ready to go. So database is ready to accept connections. So let's try spinning up our app. Now, we get an error because we have to run the migrations and seeds. And if you didn't know this already, these containers are ephemeral, like they're very temporary. So because we just spun up a new container, the migrations have not been run against it, and the seeds haven't been run. So we need to migrate it. We then need to seed it. And now we've got the data. Good to go. So we've wrapped up that CLI command into a nice compose file. But there is still one more thing we need to do. Now, another thing we can do is specify a place to actually store the data for the database itself. Now, by default, if you take a look inside of Docker Desktop, you can see that behind the scenes, there actually is a volume that it creates. And that's where it stores the data. And so that's why we technically are able to shut down the containers from Docker Compose, start them back up, and then the migrations and seeds have persisted. So we can still access that data from the API. But one of the things you might do periodically is like delete running containers, delete images. And if you want that data to persist in a consistent way, then you can create a volume inside of the Docker Compose as well. So let's do that. Now, if you take a look at their documentation, they have a section on PG data. And any other type of database that you're dealing with is very likely going to document this as well, like where are they storing the data? Now they're storing that data here. And what we want to do is we want to store that data on our computer and then map that to this location inside of the container. And you can see in their example command here, -v is how you specify volumes from the command line if you want to do that. But we can also do this inside of our Docker Compose. So in our Docker Compose, we can specify volumes. And then we're going to map someplace on our computer to the data folder inside of the container. And what I typically like to do is just create like a DB data folder in this folder right here. So this will create it here, and that's where all the data will be stored. And that way, if I ever blow away the containers or the images or whatever else, it will map it back to this folder, and all of the changes that have been made to the data in the database will persist. So let's use this. We'll now kill the container, start it back up, and it will now use that volume. But because it's using that volume, now it doesn't have any seeded data. It doesn't have any migrations that have been applied. So we're going to run into that same error that it doesn't exist. But if we run the seed and migrations commands again. So let's do an npm run db migrate. So that'll create the tables, and then we'll seed it to insert the data, and then we'll start it back up. Now that data does exist. And if we take a look, it actually is putting all of this stuff inside this DB data folder. And so this is all the stuff associated with Postgres. And we want to make sure that we don't commit this info to our Git repo, because this is a lot of stuff. So you typically only want this locally, so that way you can persist your data locally. So you always want to make sure that you add this to your git ignore, just so you don't accidentally commit and push it up. So we're going to add DB data in there. And so now this won't get pushed up, or won't get automatically tracked whenever I'm committing or adding files. But locally, if I ever remove and delete the container, all of the data is stored. And so let's actually see an example of that. So if I kill this container, and then I go over here and delete it from docker-compose, and then we have some volumes sticking around, let's actually delete those. But I will show you, I'm all over the place, but let me show you there's a command line thing you can do to this. So you can say docker volume prune, and this will delete all of the volumes that are on your machine. So that's the command line way of deleting that container. You could also just click the trash button. But at this point, there are no more volumes that exist. The containers are gone. But because I mapped it to that specific folder, if I start this container back up, it's going to use the data inside of that folder. And now I don't have to run migrations and seeds again. It still has that persisted data. Now we are just scratching the surface of the Docker-compose CLI, and then also the Dockerfile itself. So I'm going to link these articles in the description. They talk about other commands you can run from the CLI tool. And then also they talk about the Docker-compose file specification. So they talk about like the services section and the volume section and all of the other things that you might want to do inside of a Docker-compose. So you can look at that here. Next up, I will show you how to make our own custom images and containerize this API itself. But let's first talk about why we would want to do that. Now, I already showed you the endpoints that are talking to the database. Those endpoints work just fine. This endpoint here resizes images dynamically, and it needs image magic behind the scenes. So let's try visiting this endpoint. So if we go to localhost 5000, we can specify the monster number we want. Let's say we grab monster number 5. We then specify the size. So this is size in pixels. And then we do image.png. And so this will use the base image and then resize it to 100 pixels wide. Now, you notice we get an error. Image magic is not installed. So this is another potentially cumbersome thing that needs to be configured on my computer to get this API running. Now, because I'm on a Mac, I can use brew to install this. So let's just do that. If I do a brew install of image magic, that's going to add it to my machine. And then the API is actually using that command behind the scenes. Okay, so it's installed. And so now if I hit this endpoint, we actually get the image back. But I don't want to have to do that, right? And so this is something that I've also glossed over, is that anybody that wants to run this API also needs Node.js and npm, which again, they're fairly trivial to install, but it's going to vary depending on operating system, depending on potentially where you're deploying this to. So what we want to do is we want to wrap this up into a nice little box, a container, if you will, that has Node.js inside of it, has npm inside of it, and has the ImageMagick CLI inside of it all ready to go, where I can just run one command and instantly spin up the API. So to containerize this API here, we're going to need a base image. And because our app needs Node.js and npm, we're going to pick the image that is Node.js. So this is a base image that includes Node and npm. And this is the official one. And if you take a look at their docs here, they actually link to how to use this image. And they give us some examples of also a Dockerfile and a Docker-compose. We're going to specify a Dockerfile because this is how we'll create our own image. Now, the first line in that Dockerfile is going to be which specific image we want to pull in this case, the Node image. So let's do just that. In our source codes, we're going to create a Docker file right here. And then we're going to say from, and the base image here is Node. Now, like earlier, like I showed you in the Docker-compose, you can leave off the version number, but we want to specify a version number. So that way, if there are any breaking changes introduced, we're locked to a specific version. And you can see all the versions available here. I'm going to pick version 20 because that's currently the LTS. You can use just LTS as the version number like this, but that will move as LTS changes. So I'm actually just going to lock it down to version 20. From here, we want to set up this image to have everything that it needs. So if we look back at the docs, it requires the ImageMagick CLI. So we want to install that inside of this container. Now, this container is actually based on a version of Linux called Debian, and that has a package manager called apt. So if I say run apt install ImageMagick, like that, ImageMagick, that'll install the ImageMagick CLI inside of the container. Now, depending on what your base image is, your package manager might be different, but I know that this one's based on Debian, which uses the apt package manager, and so this will install the ImageMagick CLI. Next up, we want to copy the files into the container. So we want to take all of our source codes here, put it in the image, and for that, we'll use the copy command. So this says copy everything from this directory into the container, but I don't want to just put it at the root of the container. I want to put it in a specific folder. So before we copy, I'm going to specify the working directory as /app. Now, this can be whatever you'd like. In my case, this is just easy to remember. So all of my codes will live inside the /app directory inside the container. Now, in order to run this app, we will need to install the dependencies. So at this point, because all of the source codes is inside the container, it should have access to that package.json. So we're going to run an npm install. From here, we should be good to go. So we have a base image that has node inside of it. It's going to have that ImageMagick CLI. It's going to have all of our codes inside it, and it will be ready to run because we've installed all of the dependencies. So let's actually use this Dockerfile to build an image, and we're going to do that inside of our Docker Compose. So here in our Docker Compose, we're going to add another service. In this case, I'm going to call it app. And here, I'm going to say build current directory. So this will look in the current directory, find that Dockerfile, and actually build it. And then in this case, I want to expose the ports because port 5000 is running inside the container. And so for that, I will specify 5000 outside, 5000 inside. And then lastly, we actually want to run the Node.js app itself. So there is a command you can run here. And now I'm just going to say npm run dev. And so this is going to build the container, expose the port, and then actually run it. So now let's actually spin down our Docker Compose. Let's kill the local instance of our API, and then let's try a Docker Compose up. Now, it will need to pull that Node.js image because this is the first time that we're running it. But then let's see what happens. Great. So now it's going through each of those commands in that Dockerfile and then running them. And I'll just show you. So it actually ran the install of ImageMagick. That was good to go. It created the working directory, copied all the files in, did an npm install, and now the image is there. And now we can see here Docker Compose is spitting out logs, and it actually differentiates the logs depending on the container that it's running in. So any of these logs that have app1, these are logs coming from the app container. And then anything we have with DB are logs from the database container. So we can actually see that the image is running now as a container with our Docker Compose, and we can try visiting it. But now we run into an issue where we need the app to be able to talk to the database. And because right now it's actually attempting to connect to port 5432, and it can't because it's trying to do that from within the container. And we exposed 5432 to our local machine, but we didn't expose it to this container here. But what's nice is if I don't need to access this database outside of the container, I can actually just remove that port mapping. And now I can just add a depends on clause here, and I'll say that this depends on the database. And so now that they depend on each other, they're going to be in the same network so that that way they can connect to each other. Now, the other thing we'll do is in our .env, now our database isn't running on localhost anymore. It's running on this container called DB. And so if I specify the host as DB, Docker Compose and Docker have set this all up to where inside this container, DB will resolve to the IP address of the container that's running the Postgres image. And so now this should allow the app container to connect to the DB container. So we'll kill the containers. Okay, so the containers are stopped, but we actually need to do a rebuild of our app container here. Because earlier inside of our Dockerfile, we said copy all files into the image that got built. And because we've changed this .env, we actually changed that DB host value. And because this .env is being built into the image, we need to rebuild it so we get the latest version of this .env inside the image. So let's do a Docker Compose up. But if I pass in -- build, that will rebuild the container to make sure we have all the latest files inside of it. Cool. And at this point, if we visit the app, we're good to go. So now the app container is connected and able to talk to the DB container. And we can also test that image resizing endpoint just to make sure that image magic is working inside of the container. So if I specify, let's say, size of 50, and we get back an image, that means that it was able to use image magic inside the container to resize that image. One of the things we did earlier is we copied everything into this image for our Node app. But if you'll remember, we also created that DB data folder, and we don't want that to exist inside the Node container. So let's add ourselves a .dockerignore, and anything listed in this file won't get copied into your built images. So we're going to add DB data there. Also, because we're running an npm install inside the container, we don't need to copy the node modules in. So we're going to add that to our dockerignore as well. And also, if you're in a Git repo, you can add .git to that ignore file. Now from here, if I want to rebuild the images, I can do it from the command line. So I'll do docker-compose build. And in this case, I'm actually also going to pass in -- no cache. So that way it doesn't use the cache and just builds everything from scratch. We're good to go. And let's actually just do a docker compose up so we can take a look at what happened. So containers are running again. Now, if you look inside of Docker desktop, there's a few things we can do here that I actually didn't show you. So if we take a look at this app container, we can see all of the files inside of this app container. And because we put all the source code in /app, if we open that up, we shouldn't see that DB data folder, which is good, which means it ignored that whenever it built the image. The other thing is we can actually run commands inside of this container. So if you click on the exec tab here, I'm literally inside this container, and I can run commands and do everything else. Now, I wouldn't recommend doing this often because typically when you spin the container down and bring it back up, all of those changes are going to get lost. But if you ever need to poke around and kind of see what got built into your image, you can use this as well. You can also do this from the command line. So if you click this here, this will actually launch your terminal, and then you get a nice little interactive prompt where you can interact inside of that running container. And you can see the command that it runs. So docker exec -I for interactive, -T for TTY, and then we have the container image ID. But we can also just run this ourselves. So if you do a docker ps, you'll see all of your running containers. You're going to want to grab either the container ID or the name of the container, and then we can do that docker exec command. So if I do docker exec interactive TTY, the name of the container, and then sh, I get dropped into a shell, and now I can start running commands. Now, this is very useful, especially if you need to run like seed or migration commands inside the container. So let's look at that as an example. Let's actually kill all of our running containers, and then I am going to completely remove that DB data folder. So we're starting from scratch. The other thing I'll do is I'll do a docker system prune. And now this is good to run every now and then because it'll free up some space on your machine. Let's see how much space this frees up. Yeah, I freed up about 300 megabytes. So all of the cache, all of the images, all of the stuff that's not in use right now got deleted. And so that kind of freed up the space as well. And so from here, if I do a docker compose up, that's going to spin up our database and also spin up our app. But remember, we need to run the migrations and the seeds, because if I attempt to visit my API here, it doesn't have those tables. So I need to run db migrate and db seed inside the container. So we can use docker exec to do that. So if I do docker exec, and in this case, I don't need to be interactive, I just want it to run the command, I can specify the name of the container and then the command I want to run. In this case, npm run db migrate. And then we'll run the seeds. And so this is running those commands inside the container. And from here, we should be able to access the data from the API. Now, at this point, we want to be able to work on the API and like add new features without having to rebuild the container every time we make a change. And we can do that with volumes. So just like earlier, we specified this DB data volume to map the data from within the Postgres container. We can have a volume here that maps the current directory, which has the source code, to the /app directory inside the image. So let's do that right here. So we'll specify the volumes. We'll say map the current directory to /app inside the container. And now when we rebuild it, whenever that container spins up, it's going to be looking at the current working directory. And so because we're running npm run dev, if we make a file change, that's mapped inside the container and it should automatically restart. So let's give it a go. We're going to kill these containers. We will rebuild the app container. So I'll do docker compose up and we'll do a build. Now it rebuilt, but when it tried to start, we actually get this very cryptic error here. And this has to do with our node module. So when the app is running inside the container, it's running in Linux. In this case, I'm on a Mac. So locally, my node modules were built for a Mac. And we need to avoid that issue. And so because we mapped the current folder into the container, it is essentially like overwriting the node modules that got created inside of the container. So if you ever see these weird cryptic node errors, you should try doing this. We're going to create a volume that is literally just app/node modules. And so that way it doesn't use the node modules that are in my directory that were potentially installed for Mac OS or Windows or wherever you're doing this, and it only uses the node modules inside of the container. So let's do that and try rebuilding. And it looks like it's working this time. So I should be able to visit the endpoint, good to go. And I should be able to grab an image as well, good to go. Now let's try adding a change and see if the container restarts. So let's go over here. At this point, you don't have to actually know anything about Node.js. Just know that I'm going to add a new endpoint, and it's just going to be a test endpoint. So let's say I add a little endpoint here. Okay, so I have this little endpoint. I added it. If we look at the logs, we can see that this change was actually detected inside of the container, and the container restarted. So I should be able to go to images/banana and see those latest changes. Great. So when I make changes locally in the folder, it actually is seen inside the container and that process restarts, which is great. Now, this kind of development workflow works perfectly fine for this simple little API. I can make my changes, the container sees them, it restarts the process. But if you're working in other frameworks, it's not always this quick and easy. So if you ever try to do this with like a React app or a Next.js app or even like SvelteKit, a lot of times this is a very cumbersome development workflow because it actually takes a few seconds before those changes are detected, and then it needs to be rebuilt and reloaded inside the container, and that is not ideal. Now, the answer to this is dev containers. And I'm not going to show an example in this video because I could do an entire video on dev containers, but the idea is you have a specific .dev container folder inside of your source code, and that dev container folder will have a Docker compose, it'll have a Dockerfile, and then VS Code actually attaches itself to the running container itself. So you're not doing this thing where we're mapping files on your local machine into the container. You will actually be developing literally inside of the container, and it handles all of the intricacies of that. But all you'll need from that point is a Dockerfile and a Docker compose. But like I said, I can make a whole video on this. Definitely check out dev containers if you have a really slow development process when you're trying to like work inside of a Docker container like this. Now from here, you should be good to go for basic development with Docker containers. This isn't how you should do things if you're actually deploying Docker containers. We'll talk about that next. But another thing I want to show you is actually kind of what's happening here in this Dockerfile. So let's kill our containers and then just try building our app image directly. Now to build this image, we can say docker build, and we'll just do period because that means use the Dockerfile in the current directory. And then we're going to tag it, and we're going to use the same name that Docker Compose was using, which is backpack debugger's app. And so this will then build the container. And we've seen this already. We can see all of the what are called layers that are happening here. So like 2 out of 5, 3 out of 5, 4 out of 5, each of these is a separate layer. And whenever we make code changes, that is actually affecting this layer here, because if one of the files changes, when Docker runs again, it's going to see that that's not cached, and it will need to recopy and then redo the npm install. So let's make a very simple change inside of our app. And in this case, something super simple, like we'll just remove the semicolon right here from this route. But if we run the build command again, you're going to notice that it actually needs to run the npm install command again. And that's because these layers are cached in order. So if any file changed, it's always going to have to run an npm install. So one thing we can do is we can say, don't care about any file. We really only want to run the npm install if the package or package.json file has changed. So if I do a copy of package star.json. So that'll pick up both the package.json and package-lock.json and then copy that into the container. Now, npm install only has to rerun if either of the package.json files changed. not if any of my source code changed. So with this one change, now we'll have to rebuild one more time, and it's going to run that npm install. But as long as I don't change the package.json or the package lock, then those layers are going to stay cached. And so we can go in and make another code change like this. And now when we do a rebuild, the only thing it had to change was this copy command. So the build is super fast. Now, what I've showed you so far will work perfectly for development. And if that's all you're going to use Docker for, you can stop there. But if you would like to start using Docker in production as well, there's a few things we need to do to the image we've created to make sure that it's production ready. Now, one thing is, because this is a TypeScript API, it has a build process. So whenever we build it, that's actually going to output some JavaScript files. And this is actually what we want to be running when we're in production. And so we need to create a container that only has the built files here. We don't want to be using TS Node in production. So for that, we're actually going to use what are called multi-stage builds. So you can check out the Docker documentation on this. And essentially what it allows you to do is create different stages of a build inside of a single Docker file. So we're going to take the base Docker file that we wrote and create some other stages. Now we'll rename the base code here as base. So I'll just say as base, and now I have defined a stage called base. From here, we'll create an image based on this base image. So this base image has all of our dependencies, right? It has image magic and then all of our node modules as well. But now we want to create a dev container that has all of the source code inside of it as well. So I'll say from base as dev. And so now I have a stage called dev that has all of the files inside of it. And so from here, we can use these stages inside of our Docker Compose. So in my Docker Compose file, instead of just saying build with the context of this directory, we're going to specify some options. So we'll say context this directory, but we can target and specify which stage we want. In this case, we'll specify dev. And so now we're going to be using this stage, which is based on this stage. So before we rebuild the container, let's actually update our dockerignore, because locally I ran a build and it has this dist folder here, and I just want to make sure that that dist folder does not get copied into the image. So I'm going to add dist to my dockerignore as well. Now we can attempt to build. So I'll do a docker compose up and build it. So it's up and running. I can go ahead and check and see, yes, the API works. So we're good to go with our dev container. From here, I want to create a prod container. So a container that only has the dist folder inside of it, doesn't have all of the source code. So let's do just that. So we're going to create another stage, and we'll call this the build stage. So I'll say from dev, we'll say this is the build stage. And we're pulling from dev because we need all of the source code to be able to run the build. And here we'll just run an npm run build. And so this command is going to generate that dist folder. From here, we want to create our production container. Now, our production container is going to be a combination of the base image, which has all of our dependencies, and the actual built files that were created here in the build container. So we're going to base it off of the base image. So I'll say from base as prod. And then inside of this image, I want to copy the built files that happened inside of the build stage. So I will say copy. And from here, you can specify which stage you want to copy from. And so I want to copy from the build stage, and we want to copy app/dist into /app. And so now inside the prod container, it's only going to have the bundled built files inside that app directory. It's not going to have all of the source code. So this should be good to go. We now have this prod stage, but now we want to actually use it. So one thing you'll see people do is actually have multiple Docker Compose files, and they'll just prepend it with like the environment. So let's do that. Let's copy our existing one and name it .prod.yml. And then inside of here, we're going to target the prod stage instead of dev. And then I don't need any volumes here because I'm not using this for development. I just want to use the container itself. And then the command is a little bit different. So instead of running npm run dev or npm start, I specifically want to run the built files. So I'm just going to say node source index.js, because for this app, when the files are built and bundled, that's all that will exist here is this indexed file that needs to be run. So with that, we should be good to go. Now I have my prod stage ready to go. I'm pulling from it inside of this Docker Compose. Now let's try to run it. So if you do Docker Compose, you can specify -f and then pass in a specific Docker Compose file. So I'm going to pass in the prod file. We're going to spin it up, and I'll tell it that it should build. And it's working, but we see that we get an error. So my app automatically throws an error if it's missing values inside of the .env. And this is actually a good sign because our container, the prod container, does not have a .env file inside of it, right? That .env file does live in the dev container, but it does not live in the prod container because we only copied the built files over. And so one thing we would want to do for our production file here is to actually pass those environment variables in. And so we can do that in a similar way to how we're passing them in to the database. So I'll do that really quick. And so now when we spin this up, Docker is going to use the .env file that's in our directory, and it will actually pass these into the running container. And because this is for prod, we can actually specify this as production directly instead of using the node env. So this is going to run the container and now pass in those environment variables, so it should be able to connect to the database as well. So let's kill this and then try running it again, and we're good to go. So now we have the API running inside of that production container. Now, there's a lot more you should think about and a lot more you can do if you are going to be running these containers in production. For one, when you're running in production, you might not be running a database from a Docker Compose. You might actually want to connect to like a remote instance or something like that. And so these environment variables here could point to like something hosted on AWS RDS or something like that. But I will point you to this repo here that talks about Docker and Node.js best practices. So this talks about some things you should take into account if you're going to be running a node container in production. And it talks about things as like running as the non-root user and a few other things that you can take into account. Now, one of the last things we'll do here is remove some duplication in our Docker Compose files. So because I copy pasted that file, both our prod file and our main Docker Compose file have this DB service here, and I want to be able to share that. So we can do that with a base image file and then extend from it. So what we'll do is we will create another Docker Compose file. I'm just going to call this docker-compose.base.yml. And then we just need this DB. So I'm going to copy it from this file, throw it in, and then get rid of everything else so that we only have the DB service. Great. So now that I have my base file here, I want to extend from it in both of my other compose files. So in my docker-compose.prod file, I am going to remove all of this and just say extends. And here I can specify the file I want to extend from. I'll say docker-compose.base.yml. And then the service that I want to extend from, in this case, the DB service. So basically all this says is take the definition here and then expand it out here. And I'm going to do this same thing inside of my other Docker Compose file. So down here, I can get rid of this and just pull in that. And now we can test it. So if I just do a Docker Compose up, it should still start up my database and my API. And we're good to go. But in this case, I kind of just removed some of that duplication. So we have all of our base services defined in our base file here. Now, just one last little nitpick is instead of having this Docker Compose without an extension, you might also add .dev on there. I like the convenience of, especially if I'm mainly using Docker for development, if being able to just do Docker Compose up and not specify the file name is pretty great. But if you want some consistency in your naming here, you could also rename this to .dev. But now whenever you use Docker Compose, you're going to need to specify that file name like we did earlier. So we do Docker Compose -f, specify that we want specifically the dev file, and then say up. And so this starts the container. But this is a personal preference, but you can name these files whatever you want. You're just going to have to specify those names whenever you're extending them or whenever you're running them from the command line. Now, I have just scratched the surface of what is possible with Docker and Docker Compose, but I hope all of the things I showed you about the Docker CLI and Docker Compose and the Dockerfile are at least useful enough to start adding slowly into your app today. Now, if you got use out of this video, I'd love to know it. Let us know how you're adopting Docker into your development workflow. And if you'd love to know more, so of all the things that I talked about, what interests you the most and what do you want to see me dive deeper into, let us know down in the comments because I'd love to make some videos on those things as well. That's all I have for you in this one. I'll see you in the next one.